So my name is Aaron Genest, and I am an applications engineering manager with Siemens. So Siemens Saskatoon is a sub-branch of a sub-branch of a sub-branch of one of the largest companies in the world. Siemens AG is headquartered out of Munich, Germany. It's about $100 billion a year is the revenue for the company. And they do everything from building trains to factories to helping manufacture drugs to building energy systems and software. And one of the components, one of the central things about Siemens is they have a vision for a digital twin of the world. So anything that is produced in the real world by Siemens or Siemens helps produce, they also have a digital version of that. And so a large part of manufacturing now is semiconductors, computer chips. And so they have a branch of Siemens called Electronic Design Automation, or EDA, that helps with the process of building computer chips. That's what we do here. We have several subdivisions in there. Each one takes a different aspect of that problem, helping computer engineers and electrical engineers from around the world, the largest companies in the world, build computer chips and design, build, and test computer chips. But in the end, every computer chip built in the world now is using software that was designed right here in Saskatoon. Siemens Saskatoon is a center of excellence for EDA. And what that means is they've found a particular confluence of availability of labor, culture, collaboration, and, for lack of a better word, excellence, that has a deep history here. We've been building software for over 17 years, through first a startup and now through Siemens after they acquired us. And we have a track record of being able to produce high quality, advanced software and then support it and then sell it, which isn't really matched in very many other places in the world. And so Siemens has decided to name this one of those centers and has continued to invest in us over the last 5 years. Most people don't feel like a center like Saskatoon is really where you would imagine a large technology center. We beg to differ. We think that there are some pretty fortunate aspects of the way we're situated in Saskatchewan and Saskatoon that will allow us to build a very large Siemens site here. Some of those are the access to the university and to the R&D and learning and training hub that we have right here at Innovation Place and on the University of Saskatchewan campus, along with Saskatchewan Polytech. Those are really important components. We also have relationships with government and not-for-profits that are highly responsive to doing things like putting robotics and coding into schools from kindergarten all the way through to grade 12, and allowing teachers to learn how to do those things. That's something that we did over the course of just a couple of years as a province, and really it's very hard to do that in other provinces. So we can move much more rapidly because we can get all the right people in the room. The other thing is, when you build something special in a relatively isolated space, people want to help build it with you. And so we spend a lot of time working on making people feel like they're part of the organization and have an impact on the organization so that it's theirs. Once something is yours, you want to stick around and continue to build it. And so we spend a lot of energy trying to inculcate that in our team and entire site. And maybe it's just that, once you're here, it's really hard to leave because there aren't a lot of flights. So the software we build here is essential for the manufacturing of semiconductor chips because we allow the companies that are investing millions and billions of dollars in trying to create the next generation of computer chip to ensure that when they do so, it's going to work as intended. There are three components to the success of a chip, and that's the power consumption of the chip, the performance of that chip. You'd think of it maybe as the speed at which it does or the number of operations it can simultaneously complete, and then the area it takes up, the size of the chip. And those three components are extremely important for a successful design. One that consumes less power is higher performance in a smaller area is going to sell more copies than one that is not. And so knowing that you can cut the corners as much as possible on design so that you can still achieve your PPA results and have the quality of result in your chip that you need. In other words, that your chip is going to work even when it's minus 40 and you've got your phone out and the battery is low. If the chip is still working at those levels, then you've got a successful chip. The problem is that knowing that is impossible without computer simulation. And so every aspect of chip design involves some kind of simulation. Is it working as intended? Is the signal flowing properly? Is every transistor operating correctly? Are the backups kicking in properly when they are? Our software helps do those simulations in a way that gets you the most information possible in the fewest number of simulations. So the result is that you're able to, with maybe a few thousand simulations, understand if your chip is going to work when it's embedded in a tire sensor and spinning around 1 million times a minute and it's 125 degrees centigrade. Our software will tell you that answer with a few thousand simulations, whereas being able to tell that in any other condition would require millions, if not billions, of simulations. Turns out that 10-fold, 100-fold, 1,000-fold, million-fold improvement in the number of simulations makes our software worth buying.